Factoring polynomials. We look at different things when we factor polynomials. One, we want to see if it's in descending order, and not all polynomials can line up 3, 4, 5, 6, and it's based upon the degree, the power. So I have an example I wanted to work on. It's 6x cubed y cubed plus 45x squared y squared plus 21xy. So when I said descending order, I noticed that this is x cubed, y cubed, this is x squared, y squared, x to the first, y to the first. That's descending order, and it just so happens to work out both variables have the same degree in each term. Doesn't always happen that way. Polynomials means many. Poly means many. So if we have one term, we're going to have a mononomial. If we have two terms, we're going to have a binomial. If we have three terms, we're going to have a trinomial. And then anything beyond three terms is called polynomials. And when I call terms, this here, 6x cubed, y cubed is a term. And it's separated by this plus. 45x squared, y squared is a term. And there's 1, 2, 3 terms, so I would call this a trinomial. It is in descending order. Whenever we're factoring, the first thing we look at is the GCF. This means greatest common factor. So what is it that all the terms have in common that I can factor out? So it's important. Sometimes it's just a 1. Anytime your coefficient, and that's what's the number on the variable. Okay, so I apologize. Let me back up just for a second. Whenever I have a term that has an x, y, z, an alphabet with it, that's called a variable term. Anytime I just have a number, so say for example this is what I had, this would be called the constant term. And then again, this is the variable term. So I wrote off the page. But this was just an example to help you understand the meaning of it. In this case here, all of them are variable terms. And there's 3 of them here. So again, it's called trinomial. If I had more, then I would call it a poly. If I only had 2 terms, I'd call it binomial. And 1, I call it mononomial. Now, let's talk about the term. This term has a variable of x and the variable of y. The number directly in front of the variables is called a coefficient. So the coefficient here is 6. Coefficient here is 45. Coefficient is 21. Over here on this example where I was telling you that's the constant term, that coefficient is 6. And if I was to look at it, I would say 6 could have a variable on it, but that variable is raised to 0 power. And if you go back to the exponential rules and look at what's anything raised to 0 other than 0 is equal to 1, so 6 times 1. So it makes sense. We call it a constant term because it only has a number, no variable visible. And the coefficient is 6. So when I'm explaining this to you, anytime your coefficient is a negative number on the first term, we want to factor the negative out. In this case here, it's positive, so we're okay. If only 1 factors out, then that is my greatest common factor. But let's look at this. 6 is divisible by 2 and 3. 45 is 5 and 9 is 3 and 3, right? 21 is 3 and 7. So what I do when I ask myself the greatest common factor, I'm asking what is the largest number that I can pull out of this, this, and this. So I go back and look at the prime factors here. I have 2 and 3. I have 5, 3, 3, 3, 7. What I noticed is that I have a 3, and a 3. So my greatest common factor as far as coefficient goes is a 3. Now let's go look at the variable. I have x cubed, x squared, x to the first. So at most, I can pull out the x to the first, right? because I can't pull 3 x's out of 1. So at most, and all 3 of them do have an x term, so that is going to be part of my GCF. Then I go look, I have y cubed, y squared, y, and again, all 3 of them has a y value, and at most, I can pull out 1 y to the first. So my GCF here is 3xy. So I'm going to say 3xy, and in parentheses, I'm going to put all this that's left. Well, how do I know what's left? Well, what if I come over here to the side and I say 6x cubed y cubed plus 45x squared y squared plus 21xy. What if I said I divided all those terms by that 3xy? 3xy and 3xy. I can say 3 goes into 6 2 times. The quotient rule of exponents says if I divide by like bases, I subtract the powers, top minus bottom. So I have 3 minus 1 leaves me with x squared. Okay, so I have y cubed divided by y to the first. 3 minus 1 is y squared. And I have positive 3 divided into positive 45 leaves me a positive, right? 3 goes into 45 how many times? Well, if I come back to my prime factors, if I take a 3 out of it, I got 5 times 3 leaves me with 15. I have x squared, and I'm dividing by x, so that means 2 power of 2 minus power of 1 leaves me with x. I got x squared divided by y, so that means a power of 2 minus 1. I have a positive 3 divided into 21. And if I go back to my prime factors, I notice when I take out the 3, I'm left with 7. X goes into x 1 time. 1 times 7 is just 7, right? Y goes into y 1 time. 1 times 7 is just 7. And that is my factored form.